What's up everyone, welcome back. Patrick here, moving on to the next example dealing with transformation still. So if f of x equals 1 over x, we got to graph this function over here. Negative 2 f of negative 2 over 3x plus 4 minus 3. Now this particular parent function is very unique, 1 over x. If you remember, we went over it and it looked like this. We talked about the concept of asymptotes, because remember 1 over x has a vertical asymptote at x equals 0, has a horizontal asymptote at y equals 0. If you didn't watch the video where I introduced this parent function, make sure you do before watching this video, just because this function is very unique. It's a function that you haven't dealt with back in grade 10 yet, and so it's kind of new. So I'd recommend watching that video first before watching this one, because a lot of the same concepts I'm going to be mentioning in this video. A lot of things are going to carry over. All right, so a couple of things I want to talk about. First off, notice that the parent function is given. In this case, it's 1 over x. So the parent function and the transformations, they are separated. But we could have also had both of these combined. So if we combine these two, basically what would happen is this whole bracket here would be subbed in for this x. The negative 2 would be on the outside, so we'd have negative 2, and then we'd have 1 over negative 2 over 3x plus 4, like that, minus 3. So it could have also been shown in this format. Also, the negative 2 could have been distributed inside to the numerator. So it could also be shown like this. So I kind of want to talk about this for a little bit. The different formats that this particular parent function can take. So this or this are actually the exact same thing. And just more in general, we know that the general transformation format, it's AF of k bracket x minus d plus c. So if we apply this format to this parent function, basically it's going to look either like this, right? So that's one way, where that a is sort of on the outside and then you have a 1 here. But the a could also be distributed. So another way it could look is a over k bracket x minus d plus c, like that, right? So different formats that this function in particular can take, because the a value can sort of be distributed to this 1 here. So it could be in this format. So just be on the lookout with this parent function for these different kind of formats. Right? And it's really important because to get those transformation values, it has to be in a format that you personally understand. So just make sure that you're getting these transformation values correctly. However you're doing it, you got to be able to derive those from whatever function that they give you. Okay, so just want to make a note of that. Now, we know the parent function. I'm going to actually write it up here. I feel like I'm going to need more room for this one. So the parent function is 1 over x, it's given. Now we got to get the transformation values. And so notice that the general transformation format, let's rewrite it again. It's like that. So from here we could tell the a value, it's negative 2. The c value is negative 3. But what's the k and the d value going to be here? Well, notice that this bracket, it's not in this format here. We have to factor out that k value. So if we have negative 2 over 3x plus 4, we got to take out that negative 2 over 3. So we'd be left with x. And then what are we going to be left with here? Well, when we factor something out, what we're doing is we're dividing everything by what we took out. So notice here, the negative 2 over 3's cancel out. We're just left with the x. But what's 4 divided by negative 2 over 3? Well, that's like 4 over 1 divided by negative 2 over 3, which is like 4 over 1 times negative 3 over 2. Like that, the reciprocal of this multiplied. And so we'd end up getting negative 6 here. Right? Negative 12 over 2. So this would be a minus 6, like that. That's what would be remaining. And you could check it. If we take negative 2 over 3 multiplied by negative 6, notice we get a positive 4 if we redistribute that negative 2 over 3 inside the bracket. So we can actually take this and rewrite it as negative 2f of negative 2 over 3x minus 6 minus 3, like that. Right? So just be on the lookout for these kinds of different formats where you're going to have to do some work in order to get those transformation values. This bracket could have also easily been written like this, right? So you'd have to rearrange it. Could have also been actually one fraction. I mentioned this in a previous example. So this could have also been 12 minus 2x all over 3. And then you'd have to split that up into 2 separate fractions, get the 4 negative 2 over 3, and then rearrange it to that. This could have also, instead of negative 2 over 3x, it could have been negative 2x over 3. That's another thing. Another thing, I actually haven't mentioned this in previous examples, is that this could be in front. So taking this here, it could have maybe been written as negative 3 minus 2f of negative 2 over 3x plus 4, like that. And then you'd have to recognize that because this is multiplying by the f here, we know this is the a value, so it should be in front, and then we take this minus 3 and put it on the n, which would be the c value. So it could be given in this kind of format too, right? So just be on the lookout for these different kinds of formats that can happen. A lot of times you're going to have to manipulate stuff in order to get it in this format here. Anyway, so from here, the a value, negative 2, c value, negative 3. Notice the k value is negative 2 over 3. And then the d value is 6, positive 6. Remember that sign always changes. Right? So if you didn't factor out that k value here, you would have maybe thought the d value is negative 4. But it's positive 6 instead. Right? So getting it into this format is very important. So now what we got to do is graph it, and we're going to be using the mapping. So first we got to make a table. We got to make a parent table, and from that video where we discussed 1 over x, I had a table negative 2, negative 1, negative 0.25, and then, sorry, negative 0.5, my bad. This was negative 0.5 here. And then over here, I had negative 0.5, negative 1, and then negative 2. And then at an x value of 0, remember it was undefined because we said an x value is 0, that's the vertical asymptote. And then we had 0.5, 1, and 2. So this was positive 2, 1, and then 0.5. So now we have the parent table, and now we're going to transform it using the mapping formula, and it's going to be dependent on these transformation values. So all the x values we're going to divide by negative 2 over 3, and then we're going to add the d value of positive 6, and the y values are going to multiply by negative 2, and then add the c value, which is minus 3 in this case. Now x divided by negative 2 over 3, you could leave it like that. I'm going to put it in a nicer format, so it's like x over 1 divided by negative 2 over 3, which is like x over 1 times negative 3 over 2, right? Multiplying it by the reciprocal. And this negative 3 over 2, it's like negative 1.5, so I'm actually going to use a decimal here. So it's like negative 1.5x. You don't have to, right? You could keep it like this. You can keep it as negative 3 over 2 times x. I'm just going to put a decimal, negative 1.5. Just personally, it helps me see it a little bit better, right? But all of them are going to give you the exact same thing. And so what we got to do now is basically take all these x values, put them through this formula, and then all of these y values, put them through this formula. So starting with an x value negative 2, negative 2 times negative 1.5 is positive 3 plus 6 gives us 9. And then over here, we'll have 7 0.5. Here, negative 1.5 times negative 0.5, that would give us 0.75. So this would be 6.75. This 0 would become a 6. 0.5 times that would give us negative 0.75 plus 6 would give us 5.25, like that. And then we'd have 4.5. And then 2 times negative 1.5 is negative 3 plus 6 would give us positive 3, like that. Right? So these x values got transformed to these x values. And then the y values, we'd get negative 2 here, right? Negative 2 times negative 0.5 is positive 1, minus 3 is negative 2. Here we would have negative 1. Here we would have positive 1. This undefined would stay undefined, and I'm going to talk about the meaning of that in a little bit. The 2, we would have negative 7. Then we had negative 5, and then we would have negative 4. Like that. Right? Yeah, looks all good to me. Right? So this here ends up being the table for this function with this parent function. This parent function with these transformations, this is the table here. And like I said, you could test some of these values if you want. If we put this in that combined format, plug in some of these x values, you should get those y values right there. Now, let's make a graph here. And in particular with 1 over x, when we transform it, there's a bunch of stuff I want to talk about. So let's make a scale here. So we'll have 1, 2, 3, 4, 5, 6, 7, 8. Then we'll have a 9. And then we'll have 1. And then we'll have 1, 2, 3, 4, 5, 6, 7. Now the first thing I actually want to talk about is this over here. Now remember 1 over x, it had the point 0 and undefined. And what did that mean? That means there was a vertical asymptote. Remember 1 over x, it looks like this. So at that x value of 0, there's that vertical asymptote. Well, what that means here is that now at 6, there's going to be a vertical asymptote. Because notice we took this function, a d value of 6, positive 6 means we're shifting it 6 units to the right. And so this vertical asymptote is shifting to 6. And so actually that's the first thing I like to do when I'm graphing 1 over x after it's been transformed, is I like to first draw out the vertical asymptote as a dotted line. So we'll have 1, 2, 3, 4, 5, 6. So at this x value of 6, there's going to be a dotted line like that. That's always the first step that I like to do, because then it allows me to organize these points in a better way and kind of visually see what is going on. The next thing I like to do, remember that this 1 over x here, it had a vertical asymptote, so we figured out where that got transformed. And remember it had a horizontal asymptote at y equals 0, this line right here. Well, when we transform 1 over x, no matter what transformation it undergoes, it's also going to have a horizontal asymptote. And the horizontal asymptote, notice that the vertical asymptote was affected by the d value, shifting it left or right. Well, that horizontal asymptote, what do you think it's going to be affected by? The c value, shifting up or down. And in this case, the c value is negative 3. And so what that means is that that horizontal asymptote at y equals 0 gets shifted down to y equals negative 3. And so we can actually make a dotted line at y equals negative 3, which is here, for the horizontal asymptote. And that's what I always like to do first. I always like to draw a dotted line for the vertical asymptote and the horizontal asymptote. And so specifically, remember that if we take 1 over x, you may want to write this down. This is important. The vertical asymptote, if we transform this, it's always going to be x equals the d value. right? X equals a number is always a vertical line. X equals the D value, positive 6. And then the horizontal asymptote is always going to be y equals the C value. Remember, y equals a number is always a horizontal line, and the horizontal asymptote is always going to be the C value. In this case, it was -3, right? So you may want to write this down for 1 over x in particular. And always start your graph with those two asymptotes, because then from there you know when you plot these points what kind of shape it should be. It's always going to be in this kind of shape, right? These might get reflected, so it might be like here and then here, but it's always going to be in one of those types of shapes. And just knowing where that vertical and horizontal asymptote is going to help you visualize these points after you plot them and the shape that they should take, right? So this here is pretty important. It's a pretty nice trick for graphing these. And so now, knowing these asymptotes, let's plot these points. Let's see where they're going to go. So 9 and -2. Notice that that's going to be like down here. 7.5 and -1, that's going to be like here. And then 6.75 and 1, that's going to be like here. And so notice that we can tell this is going to look like this. Remember, it's never going to hit this horizontal asymptote. This is going to keep going on forever. Okay, I'm going to probably erase this after and kind of make this graph a little bit scaled out. But let's just finish plotting these points for now. Right, so that's this portion of the graph. And then here we got 5.25, which is here, and -7. And -7 is all the way down here. And then we got 4.5 and -5, which is like, yeah, it's like here. And then 3, sorry, this was 5, 4, 3. 3 and -4 is like over here. So notice this portion of the graph looks like that. Right, so this is how the graph looks. And if we kind of scale this out, I'm going to erase these because we won't have to use these steps anymore. Hopefully you got them written out by now. If we kind of scale out here, basically the way this graph looks is we got this x equals 6 horizontal asymptote, y equals -3. And then connecting these, it looks like that, if that helps you see it a little bit better. Right, so this 1 over x, which looks like this. Sorry, I'm making graphs everywhere here. It's kind of limited room on the whiteboard. So 1 over x looks like this, got transformed to this over here. Okay, and you can go through these transformations. So I'm going to erase this main graph here, and then let's talk about some of these transformations. So the a value was -2, the k value was -2 over 3, the d value was +6, and then the c value was -3. What happened here? Well, there was a reflection in the x-axis, because the a value is negative. There's a vertical stretch by 2. This one's a little tricky. So it's negative, so there's a reflection in the y-axis. And then remember that if k is between 0 and 1, the absolute value of k, let's forget about the negative. We already said it's reflected in the y-axis. If you look at the absolute value of k, 2 over 3, that's between 0 and 1. And when it's between 0 and 1, we said that there is a horizontal stretch by the reciprocal, 3 over 2. Just be careful with these descriptions here. Right? So this is a fraction, 2 over 3, so there's a horizontal stretch by 3 over 2. And then, actually, you know what? One more thing I want to mention here is that sometimes you'll get fractions that are above 1. But because it's a fraction, sometimes students get confused in thinking it's between 0 and 1. Now, 2 over 3 is between 0 and 1, but what if the k value was 5 over 2? Notice that 5 over 2 in decimals, that's like 2.5. And that is greater than 1. And so the description for this would actually be a horizontal compression by 2 over 5. But sometimes students will see a fraction and they'll get confused because usually with fractions we're used to them being between 0 and 1. And if the k value is between 0 and 1, it's a horizontal stretch by that reciprocal. But sometimes the fractions could actually be greater than 1. So just be on the lookout for those. That's another common mistake that I've seen as well. But in this particular case, 2 over 3, it is between 0 and 1, which ends up being a horizontal stretch by the reciprocal, 3 over 2. This d value of 6 means we go 6 to the right. And then a c value -3 means we go 3 down. Okay, so now what we can do is we can actually apply these transformations to that parent function, which looks like this. Now, one thing I want to mention, there's a reflection in the x-axis, so this would go up here, and then this would go down here. But then there's also a reflection in the y-axis. So notice that this then would become this again, and then this would become that. So if there's both a reflection in the x-axis and the y-axis, for this parent function, they actually cancel out and become nothing. And the reason is because if we have 1 over x, well, if there's a reflection in the x-axis, that means the a value is negative, so we'll have like a -1 of 1 over x. And if there's a reflection in the y-axis, then the k value is -1, and that'll be a negative down here. And then notice these negatives will just cancel out to a positive, and we end up with 1 over x. And so that's why when you have a reflection in the x-axis and the y-axis, for this particular parent function 1 over x, those just net out to no transformations happening. Remember, it's only for this parent function here. It doesn't apply necessarily to the other parent functions. And then a vertical stretch by 2, horizontal stretch by 3 over 2. It's a little tougher to visualize. Basically, a vertical stretch kind of shifts this out. And then a horizontal stretch kind of actually brings it back to this. If we like stretch this out, it's going to end up looking more like this, right? Stretch this out, this is going to shift back over here. And then the same thing here. This is going to kind of stretch out. This is going to shift towards that. This is going to shift back towards that. It's almost like a vertical stretch and then a horizontal stretch. For this parent function, they kind of like nullify each other. And then what happens is we're going to go 6 to the right, taking this vertical asymptote, shifting it 6 to the right, and then 3 down, taking the horizontal asymptote, shifting it 3 down. So we end up with that graph right there. Right? So these are the transformations that happen. Now, the domain and range, actually, you know what? What I'm going to mention for the domain and range, in particular, for 1 over x, when it gets shifted, the domain is always going to be XCR. X cannot equal the d value. And the range is always going to be YER, and y cannot equal the c value. X cannot equal the vertical asymptote, y cannot equal the horizontal asymptote. It's always going to be in this format. So the d value in this case, +6, right? And then the c value, -3. And so that's the domain and range for this particular graph. So it's always x cannot equal the d value, y cannot equal the c value. And then if we show it in a different format, the domain would be x as an element from -infinity to 6, or from 6 to +infinity, like that. And in general, it would just be from -infinity to the d value, or from the d value to +infinity. That's always going to be the domain in interval notation for a 1 over x transformed graph, and it's circle brackets here. It's not inclusive of the 6. And then the range is always going to be y as an element from -infinity to the c value, or from the c value to the +infinity. And the c value in this case is -3. And then this is -3 here. Right, so 1 over x is could be tricky in particular, especially with that vertical and horizontal asymptote. You got to worry about that when you're graphing. But Just remember the vertical asymptote is always the D value. Horizontal asymptote is the C value. Draw those asymptotes first before plotting the points. Just going to make your graphing a lot smoother. And yeah, that's pretty much it. So this graph on these transformations on this parent function is that graph. These are the transformations in words, and then we got the domain and range.